Alright guys, here are the notes for Chapter 6, Section 6. I'm going to fill in a bunch of stuff with you and do some of the examples with you, but then I'm going to expect you to do some of the examples on your own. When I come back to class on Thursday, I'm going to be checking your notes to make sure that you did some of these examples on your own. You're also responsible for the homework at the end of the section. So in Chapter 6, Section 6, we're performing similarity transformations. In this section, you will perform what are called dilations. So a dilation is a transformation that either stretches or shrinks a figure to create a similar figure. The center of dilation is the fixed point, and that should not say up, about which the figure is enlarged or reduced. So the scale factor, and remember we talked about this, I believe, before. We usually use the variable k to represent the scale factor. The scale factor is the ratio of a side length of the new figure to the corresponding side length of the old figure or the original. So K is new over old. So keep that in mind as you continue to work along here. Now, something that is important to know is you can describe a dilation with respect to the origin using what's called coordinate notation. Now, if you look here, it says x comma y. Those are the original points, the original figure. And when you multiply x and y by a given scale factor, those would represent the coordinates of the new figure. If you have a k that is between 0 and 1, so you have a decimal, if you look here, whoop, then that represents a reduction, so you're making it smaller. If you have a k of bigger than 1, then that's an enlargement. So some of you said, well, may be thinking, well, what about if k equals 1? Well, if k equals 1, then there's no change at all. Okay, so we wouldn't typically ask you to use a k of 1 because we'd be saying, hey, take a figure, multiply all the coordinates by 1. That's not going to change it, so you're looking at the same figure. So here's an example where we incorporate the coordinate notation. It says, draw a dilation of a quadrilateral ABCD with vertices 2, 1, 4, 1, 4, negative 1, and 1, negative 1. Use the scale factor of 2. So I'm going to start by graphing the original figure. So 2, 1 is my first point. 4, 1 is my next point. 4, negative 1. And then 1, negative 1. So here's my quadrilateral right here. And this is A, B, C, and D. So now if I have a scale factor of 2, if you notice the notation up here, what I'm asked to do is multiply both the x and the y by the scale factor. So if A is 2, 1, A prime is going to be 2 times 2 and 1 times 2, or 4, 2. B is 4, 1. So the coordinate for the new image is going to be 4 times 2, or 8, and 1 times 2 is 2. If you notice here, there is a notation. These are primes. It's how we indicate that it's the new figure and not the original. If C is negative 4, 4, negative 1, okay. Then the new C would be 8, negative 2. And if D was 1, negative 1, then my new D would be 2, negative 2. So if I draw that, I'm going to graph those points in red. So it would be the point 4, 2. It would be the point 8, 2. It would be the point 8, negative 2. And 2, negative 2. So that red image, A prime, B prime, C prime, D prime, is the resulting figure. So that is the new figure, which has a K of 2 over 1. Notice how it's bigger, or 2, obviously. Notice how it's bigger, which should always be true if your K is greater than 1. So if you take a look at answers, you will see that you have an example. So example 2 is something for you to do on your own. That's something I'm going to be checking on Thursday that you've done that. The only thing we didn't talk about is B, verify that the two triangles are similar. Remember that you have 3 ways of doing that, either using AA similarity, SSS similarity, and SAS similarity. The hint that I'm going to give you for that particular example is, you know, the distance formula. So you can use the distance formula to find the length of all the sides, and you should be able to compare those sides once you've found all their lengths. Alright, we're looking at the 5th slide. This is pretty much exactly like the previous 2 slides. So again, I'm going to leave this one for you guys to do. So guided practice again. I'm going to ask you guys to do this, and I'll be checking this page when we come back on Thursday. If we look at the next slide, real world problem with which Jalen loves so much. So you're making your own photo stickers. Your photos are 4 inches by 4 inches. The image on the stickers is 1.1 inches by 1.1 inches. What is the scale factor of the reduction? So keep in mind that since we know it's a reduction, right off the bat we know that K should be less than 1 but greater than 0. And remember what I said is K is new to old. So the new length, the length that I want it to be, is 1.1. And then your original is 4. So if I put 1.1 over 4 in my calculator, I get a K of 0.275. Now, if you got a K of greater than 1, then that would be an enlargement. And since it specifically asks you for a reduction, you know that you have a problem or a mistake with that. So now it says, what if, in example 3, what is the scale factor of the reduction if your photo is 5.5 inches by 5.5 inches? So your original, or your old, is 5.5, and we still want to keep it at 1.1. So my K here would be 1.1 over 5.5, which is 1/5, or 0.2. So this is a good problem here on this standardized test practice. You want to create a quadrilateral EFGH that is similar to quadrilateral PQRS. What are the coordinates of H? So here's my thought. Let's take corresponding points. So for example, if you look at the order that they're named, G and R are both the third letters, so G and R are corresponding points. So let's take a look at what their coordinates are. So R is at the coordinate 0, 2, or has a coordinate 0, 2. And G is 0, 6. So tell me, what did I do to the x's? Well, I don't know. I could have multiplied 0 by anything. But I can see clearly on the y that I multiplied by 3. So I can check to make sure that the x has that same scale factor, which it's going to for us at least. There could be situations where the scale factor is different, but for our purposes, it's going to be the same. So if I look here, P1230, if I look at E, I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Hey, look at that. 3 times 3 is 9, 2 times 3 is 6. So my K is 6. They don't ask me for my K, they ask me for the coordinates of H. And if you look at the way that it's named, H corresponds with S. So if you take point S, which is right here, find that coordinate. So that coordinate is 1, 2, 3, 4, 1, 2, 3, 4, 5. 4, comma, 5. Then you should be able to multiply for H 4 times K and 5 times K. Well, we said K is 6, so 24, comma, 30. And I look, what the heck? That answer's not there. All right, let me see what I did. Did I do something silly? Coordinates of H. It's times 3. Oh my God, I'm so silly. Did anyone notice that? K is not 6, it's 3. All right, let me fix it. So it should be 12, 15. Yay, that's there. All right, so using your K to find the other coordinates. That's just it. Here is your homework. So you have a couple of those guided practice problems to do. Your homework to do, which is right here in this slide. When we come in on Thursday, I'm checking to make sure you did your guided practice problems. Any examples that I didn't do, I'm making sure that you have done, as well as the ones that I did. So when you go into your notes, you want to fill in your notes, make sure everything, looks the way it should, and is filled in appropriately. And then also you're going to submit your homework, which I will post to Edmodo. So have a good half day, enjoy your time off, and I will see you on Thursday morning. Bye.